Good morning. I, Ms. Radhika Sunil Malpani, welcome you all to the Faculty Orientation Program for the course Computer Networks 2024 pattern, powered by Savitribai Phule Pune University in association with Keystone School of Engineering. This course has been designed for computer science and engineering, computer science and design, and computer science and engineering data science. It is my pleasure to welcome Dr. Nilesh Uke sir, Chairman of the Board of Studies for Computer Engineering at Savitribai Phule, Pune University. Dr. Sandeep Kadam sir, Principal at Keystone School of Engineering. All the subject experts and faculty members. To mark an auspicious beginning to today's faculty orientation program, we shall now invoke the blessings of the goddess of knowledge, wisdom, and arts. I request all the virtual attendees to kindly join us in reverence as we play the Saraswati Vandana.
या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीमभयदां जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थिता वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदा
I now request our HOD, Professor Sagar Raje Bhosle sir, to give us the overview of today's program.
Am I audible?
Yes, sir. Yes, sir.
Thank you. Respected Chairman, Board of Studies, Computer Engineering, Dr. Nilesh Uke sir, respected Principal, Dr. Sandeep Kadam sir, esteemed subject chairman, distinguished resource person for today's program, Dr. Shivaji Lahane sir, Dr. Ranjana Dhake madam, Rahims madam, from industry, Imran Tambodi sir and Pranav Chitnis sir, deans, HODs, faculty members, and all dear participants. A very good morning to everyone. It is my privilege to present a brief overview of today's faculty orientation program on computer networks, organized by Department of Computer Engineering, Keystone School of Engineering, Pune, under the guidance of Board of Studies in Computer Engineering, Savitribai Phule, Pune University. With the implementation of the revised curriculum, computer network has been introduced as a common core course for 5 different undergraduate programs. As Radhika ma'am said, it is this course is for computer science and engineering, computer science and design, and computer science and engineering data science. Since this course caters to multiple programs, it is essential that faculty members have a common understanding of the curriculum, course outcome, teaching methodologies, laboratory implementation, and assessment strategies. Throughout today's orientation, the Board of Studies members and subject experts will discuss the philosophy behind the revised syllabus, unit-wise content, laboratory guidelines, and the best practices for effective course delivery. The sessions are also intended to provide a platform for interaction, clarification of queries, and sharing of academic experiences. I request all the participants to actively engage in today's session and make the most of this valuable opportunity. Thank you, and I wish you all productive and enriching faculty orientation program. Thank you. Over to you, Radhika ma'am.
Thank you, Sagar sir. I now request our principal, Dr. Sandeep Kadam sir, to share their thoughts.
Thank you, Professor Radhika. Good morning to everyone present over here for this virtual faculty orientation program on computer networks for third year engineering students of Savitribai Phule Pune University. First of all, I would like to thank all the authorities of Savitribai Phule Pune University and Honorable Dr. Niklesh Uke sir for giving us this opportunity to host this faculty orientation program for the revised curriculum of third year engineering students. I'm also thankful to Dean Dr. Rao Saib sir, the program coordinators of third year syllabus revision, all the members of the team for computer network syllabus revision, and everyone, those who have contributed in revising this particular curriculum. I would like to congratulate everyone, those who have contributed for design of computer network syllabus for successful design and announcement of this curriculum. I hope all the faculty members, those who are joining today's FOP, will have good takeaway. The team of curriculum design will be sharing their thoughts, the objective behind designing of this curriculum, and best innovative practices to implement the curriculum from this academic year. Also, there are a few industry people who can share their views about implementation of the practical assignment, practical tasks, which are being suggested in the curriculum by Savitribai Phule Pune University. Thank you once again, everyone, for joining today's faculty orientation program. And on behalf of Keystone School of Engineering, I welcome you to this faculty orientation workshop and congratulate computer engineering department and Professor Sagar Rajabosle, who is coordinator of this faculty orientation program, for successfully organizing this the workshop. And once again, I would like to extend my sincere thanks to Dr. Nilesh Ukesh sir for having faith in organizing this workshop and giving this opportunity and responsibility to Keystone School of Engineering. Thank you.
Thank you, Principal Sir. To set the right direction for today's session, it is now my privilege to invite respected Dr. Nilesh Uke sir to share their thoughts.
Good morning.
Good morning, sir.
Good morning, sir.
Morning, sir.
Thank you for inviting me. And I think this is the third or fourth FOP we are having. Dr. Kadam, Dr. Ajay Bhosle, and other faculty members and today's participants. Computer network is our core subject. And we have purposely added into this thing into third year. We will have its corollary subjects in final year also. And most of our students turn towards networking and networking jobs. Because being a core subject, every minutest detail should be taught in the class. Being an era of artificial intelligence, try and see what tools we can teach to students while delivering computer networks information. Whether it is troubleshooting or maybe the layers or something which is coming new, refer good articles. If at all you can conduct certain assignments in the class so that student really understand how to design a network, not just all the layers, how to design a network for a educational institutes or a power plant or a military base station, whatever. Because if the student do not go to as a system analyst or a programmer, we want those students to go as an network administrator or a network engineer. Therefore, this curriculum is very important. If you have something to change in the contents, do let us know. I will still make efforts in changing those contents, and we will upload the new syllabus on the university's website. Thank you, Dr. Sandeep and Dr. Sagar for arranging this FOP. And I wish you a very best luck for content delivery and have a nice learning at the end of this day. Thank you very much, and over to you, sir.
Thank you, sir.
Thank you, sir. Let us stand together in unity and pride for our nation. I request all the participants, both on campus and joining us virtually across screens, to kindly stand in attention for national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I hereby declare the formal end of inauguration and I hand over the session to Professor Srushti Gunthe ma'am.
Good morning to all of you. I am Srishti Gunte, working with Computer Department at Keystone School of Engineering. Now, we will start with our sessions, which are covering a computer network units. It's my proud privilege to introduce our first resource person, today's faculty orientation program, Dr. Shivaji Ramdas Lahani. He is currently serving as head of the Department of Information Technology at PVG College of Engineering, Nashik. He holds PhD in Computer Science and Engineering from NIT Surat, along with ME and BE in Computer Engineering, Computer Science and Engineering. With an impressive 21 years of academic experience, Dr. Shivaji Lahane has made significant contribution in teaching, research, curriculum development, and faculty monitoring. His expertise in computer science and networking has inspired countless students and teachers. His profile highlights strong expertise in computer science and engineering with skill in programming language such as C, C++, Java, along with networking and simulation tools like NS2, NS3, Wireshark, and Cisco Packet Tracer. He is also specialized in computer networks, IoT, blockchain, cloud computing, wireless sensor network, and network security, supported by PhD focused on optimizing routing techniques for dense wireless sensor networks. Today, he will deliver the session on Unit 1 and Unit 2 of Computer Network syllabus. Dear faculty members, please welcome Dr. Shivaji Lahane. I request sir to please take over the session. Thank you. I kindly request Shivaji sir to please take for the session.
केलं नाही काढून टाकले तर कसे करतील ते मॅडम
I request coordinator to please unmute them.
Hello.
Yes, sir,
Sir,
you
you
are
are audible.
Okay, thank you. Is my screen is visible?
Yes, sir.
Okay. So good morning, everyone. Today we are having faculty orientation program. So, 1 minute. Okay. So this is the subject for third year computer engineering for all 5 stream subject, 5 different courses: computer engineering, computer science and engineering, CSD, CSE, and data science for third year computer engineering. So this is the structure of our computer network teaching scheme. We are having 3 hours weekly theory lecture and examination scheme, 30 marks for the CCE and 70 marks for the end sem exam. After completion of this course, the 3 credit point will be reflected on the student's mark sheet. So before studying this subject, student required few prerequisite courses which are studied in the last second year, like digital electronics and logic design, discrete mathematics, computer organization, and microprocessor. These are the course objective which is given or included in our this CN subject. First, introduce fundamental concept of networking, hardware, software, and reference model. Develop knowledge of physical layer, data link layer, network layer, transport layer, and application layer with the emphasis on design issues, services, and protocols based on the different respective layer. Equip student with the ability to analyze and compare routing, error detection technique, error correction technique, congestion control method, quality of service mechanism in this subject. Then familiarize a student with the wide use of different protocols, connection-oriented protocol, connection-less protocol, and different technology, which is used in the multimedia and wireless network, and strengthen the problem-solving skill through case studies and exemplars that connect theoretical concept to the real-world application in the form of case studies. So these are the course outcomes, which is as per the guideline given by the BOS chairman and Board of Studies of SPPU. We have designed this syllabus. 5 units are designed and each unit having their own course outcome. So my session deals with the first 2 course outcome, that is the CO1 and CO2. CO1 is based on the unit number 1 and CO2 is based on the unit number 2. Unit number 1 explain the fundamental concept of computer network, layered architecture, and physical transmission media. Then after completion of unit number 2, student will able to understand, apply error detection, error correction, and reliable data transfer technique at the data link layer. I will directly switch over my particular CO1 or CO2 point I will cover in my session. These are the content of unit number 1. In total 9 hours, we have to cover the unit number 1. And the content of unit number 1 is Introduction to Computer Network. We have to briefly describe the basic usage application of that computer network to the student, different networking network types, that is a LAN, WAN, MAN, and what is internetwork, different network software, what is protocol, what are the design issues layered of that protocol, what is connection oriented, connectionless, then service primitives for the and its relationship between the services and protocol. Then 2 different models we have to study and teach to the student, that is OSI model and TCP/IP model. At the physical layer, it deals with the guided transmission media, wireless transmission media, then telephone system, narrowband and broadband communication system. Along with that, we have one case study, that is comparison of OSI and TCP model in real world network. I will directly start the first unit. In briefly, uses of computer network. When two persons or two computers or two entities or two peers are communicating with each other, without network, the communication will not possible, the session will not complete. So for that purpose, we require a computer network. It may be a wire-oriented network or a wireless network. Normally, in our traditional way, in business, your home or mobile or social media, we are using the networks. So these are the scenario given in two types, either peer-to-peer network or client-server type of network. We can configure or deploy the network by using peer-to-peer configuration or client-server configuration. This is the scene given as a client server type. The client will send the request to the server will receive the request, and accordingly, the data available with the server will reply accordingly. If the data is available, server will give reply accordingly. Otherwise, some error message or some unavailable data, likewise, the message will be. So in this way, the client server communication is carried out in the form of request reply communication. Before sending the client request to the server, we must have take the care. Our server must be on continuously on 24/7 by 360 days. Then and then client request will be received to the server. Client will send the request to the server. Accordingly, the available information server will give reply by using the network connected between the two machines. So network applications, there are so many applications, access to remote information, remotely, person-to-person communication, interactive entertainment. Nowadays, we are using the entertainment at our home, television, likewise. So that is the application, electronic commerce. These are the application of computer network. This is the example given of peer-to-peer network. So peer-to-peer network and client-server type of configuration or deployment. In peer-to-peer network, every node has an equal administrative power to works. Every node is act as a client, every node is act as a server, and that there is no any specific server or any specific client. In peer-to-peer network, every node has an equal administrative powers to work or configure. Under the title of network hardware, uh, we are having a local area network, metropolitan area network, wide area network, wireless network, home network, and internet network. So when we are using peer-to-peer type of network, we require point-to-point link for communication purpose. When we are using client-server type of deploying client-server type of network, we require broadcast link to communication purpose. So these are the two different links. One is for one-to-one and one-to-many. This is the network types scenario is given in this figure. So example is given, then interprocessor distance is given, and the processor located where, that is given in the second column. For example, personal area network, the interprocessor distance is 1 meter and located within the square meter. For local area network, the network is deployed in single room, single building, single campus, and the distance will be ranging from 10 meters to 1 kilometer. For metropolitan area network, the network will work on the city and distance covered 10 kilometer. Wide area network will work on the country or continent and distance will be covered from 100 kilometer to 1000 kilometer. And over the World Wide Web, the network will use or work on the planet, and distance will be covered, interprocessor distance between the two machines will be covered beyond the 10,000 kilometer. This is the first local area network. Whenever we are deploying the network, we have two different types of topology, logical topology and physical topology. Based on your requirement, you have to configure the network. If the logical and physical, these are the two topology. What is mean by physical? Physical means the topology look like by using our naked eyes, that is physically, that is the physical topology. And logical means the data transmitted through the communication channel logically in a manner, that topology is nothing but the logical topology. We are having 5 different topology options to deploy any type of network: bus topology, ring topology, star topology, mesh topology, and hybrid topology. In this example, given the bus topology and ring topology, I will not give detail of each topology, just the brief of the local area network. Then metropolitan area network is the bigger network that works on the city. and that covers the distance beyond the 10 kilometers. And they are using the DQDB architecture, distributed queue dual bus architecture used in the metropolitan area network. They are having the full duplex type of communication. The third wide area network, more than two small local area network integrated in one network. Suppose here 4 different LANs are integrated in one network by using the subnet. Subnet is nothing but the integration of router and communication link that creates the subnet, and that will work over the wide area networks. Then different networking softwares are there, protocol hierarchies, network issues for the layer, connection-oriented, connection-less services will be there, some socket primitives will be there, and their relationship. We will see detail in one by one. So under this network software, we are having a detailed study of the TCP/IP model and OSI model. So OSI model is a 7-layer model and TCP/IP model is a 5-layer model. So protocol is nothing but in our network, everywhere protocol, we have to follow the protocol in our traditional life, in our official working style. So everywhere, every layer, the protocol will be there, either network or oral communication. So every layer define their own protocol for communication purpose. So host 1 number and host 2 number are communicating with each other. The layer 1 to layer 1 communication is carried out horizontally by using the protocol deployed at the layer 1. Layer 2 communication at the both the machine at the same layer is carried out the protocol deployed at the layer 2. Similarly, 3, 4, 5. So horizontal communication is carried out by using the protocol defined or deployed with respect to particular layer. And what vertical communication is carried out between the adjacent layer in the same machine, the interface configured between the two subsequent or adjacent layer. That is the communication style. So likewise, so physical layer from host 1 to host 2, physical layer data will be sent or in the form of message. Then at the physical application layer, top layer, 5th layer is application layer. Message will be sent to the presentation layer. Then later on transport layer, then later on network layer, then data link layer and physical layer. So top to bottom approach is used at the sender side and bottom to top approach is used at the receiver side. So in this manner, the communication between the two machines is carried out. Vertical communication is carried out in the same machine by using adjacent layer interface configured between the adjacent layer. Horizontal communication is carried out by using the respective protocol resided or defined in the particular layer. These are the connection-oriented and connection-less services. Normally, when the actual cables or media used, that is nothing but the connection-oriented network, and without any actual cables, the network is called as a connection-less network. In connection-oriented network, the TCP protocol will work, and in connection-less network, the UDP protocol is work. So TCP is the reliable communication protocol. They are using a packet as a data type. And UDP is the unreliable communication network, and datagram is the data type used at the connection less services. And the examples are given with respect to the particular connection oriented and connection less services. These are the socket primitives. Means whenever we are using the socket programming or we are communicating from one machine to another machine, we have to use these socket primitives. Listen, connect, receive, send, disconnect. So every method has their own, we can call it as a self parameter. By using socket programming, we have to pass the particular parameter to the particular primitives. Then and then the communication can be established between the one machine to another machine. Likewise, this is the two machine, client machine and server machine. So client machine, the operating system inside that kernel protocol stack in the form of TCP/IP. We are considering TCP/IP protocol stack. Then drivers, the system calls will be there. Then server is already on, switch on. Then client send the request to the server. Server will receive the request and give the acknowledgement. Every time the three-way handshake mechanism or three phases will be maintained before communicating from one machine to another machine. Like sending the request to establish the link, then request will be established in first phase. Then second phase, data will be sent, then acknowledgement will be received for the sended data. It may be a positive acknowledgement, negative acknowledgement, or corrupted packet data acknowledgement. acknowledgement in the second phase. Third phase, if my communication or session is over, then client will send the disconnect message to the server machine. Server will receive the disconnect message and can disconnect the link. So this is the three phases always involved or possible, always implemented in that communication. Send request, send data, and disconnect request. This is the services to provided from upper layer. So layer K is suppose middle layer, K plus 1 is the upper layer and K minus 1 is the lower layer. So layer K is providing services to upper layer and taking the services from lower layer. So in this way, the relationship between the services from bottom layer to upper layer and with the middle layer is correlated with this figure. The reference model, OSI reference model, TCP/IP reference model, and comparison we are having. This is the 7-layer protocol architecture. TCP/IP is the 5-layer, OSI model is the 7-layer. In bottom to top approach, the sequence of layer is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So I already told you the vertical communication is carried out between the adjacent layer interface between the deploy at the same adjacent layer, and horizontal communication is carried out between the respective protocol resided in the particular layer. But whereas the every layer has their own data type or data format, they are expecting the data in that data format. Suppose at the right corner, see the name of unit exchange, that is data format. Physical layer, the bit is the data type because our computer understands the binary 1010 digitally. So bit is the data type at physical layer, frame is the data type at network data link layer, packet is the data type as network layer, and transport layer, segment or transport protocol data unit, or at the top 3 layers, session layer, presentation layer, and application layer, the message as it is the data type. This is the comparison, or we can call it as a OSI model having 7 layer, TCP/IP model having 5 layer. Why 5 layer? In some book it is mentioned 5 layer, in some book it is mentioned 4 layer. Above top 3 layer integrated in 1 layer, that is called as application layer, and bottom 2 layer, data link layer and physical layer integrated in 1 layer, that is called as host to network layer. So in that case, the TCP/IP model is a 4 layer. When we divide the host to network layer separately in the physical and data link layer, the TCP/IP model is a 5 layer model. Okay. This is the protocol recited in the TCP/IP model or 4-layer model. Physical layer, they are using the different networks. That is at the bottom layer, ARPANET, Advanced Research Project Agency Network, then satellite network, packet radio network, and local area network, or beyond that, wide area network or metropolitan area network. Network layer, the IP protocol is used. At the transport layer, when we are using the connection-oriented network, TCP protocol will be worked. When we are using the connectionless network, UDP protocol will work. At the application layer, the Telnet, FTP, SMTP, and DNS protocol will work for this 4-layer model. Then how we can compare the OSI model with the TCP/IP model by using that services provided with respect to the model. So what are the services of TCP/IP model, OSI model? What are the interfaces configured for TCP/IP model and OSI model? What are the protocols they are involved for the different model? Based on this particular parameter, we can compare the OSI model and TCP model. Then next point, guided transmission media. Guided means wired-oriented media. Normally, we are using the wired. We are having 3 options to choose to deploy the network by using twisted pair cable or coaxial cable or fiber optic cable. Twisted pair cable is divided into 2 types: unshielded twisted pair cable, shielded twisted pair cable. Unshielded twisted pair cable is nothing but the extra, no any extra shield is given over that. Simple wire is twisted inside the plastic cover, that is called as a unshielded twisted pair cable. And in shielded twisted pair cable, the extra metal shield, second layer, outside layer is called as a plastic cover, middle layer is called as a shield, and then insulation and then copper. So extra shield will be used for the shielded twisted pair cable. These are the different connectors used for the shielded and unshielded twisted pair cable. For a 4 point or 2 pair, we are using a different connector. For 3 pair, we are using different connector. For 8 pair, 4 pair, 8 conductors we are using. So in our LAN, we are using the 8 conductors, that is the 4 pair. Then along with that, we have to give the brief information to our student, how that crimping methodology will be used to connect that connector to the cable. There are 3 different methods: straight through crimping method, crossover crimping method, and rolled over crimping method. You have to give the brief description or knowledge about this crimping method while discussing with this type of cable. The second type is coaxial cable. Then inside the copper core will be there. Then insulating material will be there. Threaded outer conductor will be there. And outside layer is called as a plastic cover. That is the coaxial cable. The name itself gives the single axial communication. That is called as a coaxial communication. The name itself gives the idea, the single axial communication. And the connector used by the single axial communication cable is PNC connector, terminator, then T connector. Then third cable is a fiber optic cable, and they are having glass of cladding and jacket. 1 minute.
Keystone online post बन कंटेंट मागायचं ब्लॉग करते सेकंड मीटिंग बंद पोस्ट प्रीमियमचे ना पोस्ट त्यांना बदल
Okay. Thank you. Sorry. Then next, wireless transmission. So the electromagnetic spectrum, then radio transmission, microwave transmission, infrared and millimeter waves, and light wave transmission. These are the topic we need to cover briefly under this title, wireless transmission. This is the case study. You have to visit to the our college network server room and compare the OSI model, TCP/IP model, where the OSI model is reside or TCP/IP model will be reside in our network. That is the case study for us. The second unit, that is the data link layer. After completion of the unit number 2, we will achieve the course outcome 2, that is the CO2. So unit number 2 is deals with the data link layer, that is the second layer. Second layer, the data type is frame. So everything is related to the frame about this data link layer, second unit. Under the data link layer, services provided to the network layer, that is the upper layer. What are the framing and addressing techniques, design issues of the data link layer, error control method, flow control method, reliable data transfer. And under the error detection and correction technique, some techniques are used to detect the error and correct the error, like parity, checksum, CRC, basic error correction concept, likewise. And then data link layer protocols, some elementary protocols will be there, like a stop and wait protocol, sliding window protocol, and some ARQ protocol, automatic repeat request protocol. ARQ, there are 3 different protocol under ARQ, automatic repeat request method. Under that, stop and wait ARQ, go back N ARQ, and selective repeat ARQ. We have to cover these 3 method under ARQ method, and some examples are given, like a packet over the sonnet, and one case study is given on CRC error detection in the Ethernet or sonnet backbone deployment in the telephone network. So what is framing? Our data link layer deals with the complete data type frames. So everything is about the framing. The data link layer needs to pack bits into frame so that each frame is distinguished from another. So that is the framing. There are 2 methods for framing: fixed size frame and variable size frame. This is the frame in a character-oriented protocol. How the frame will be created? The flag will be at the trailer and header part. The flag will be there. Then before header, the one flag. Then after trailer, one flag will be there. And in between the header and trailer, some data will be there. That is number of bits. Data from upper layer, variable number of characters is included in this middle part. Byte stuffing is the process of adding 1 extra byte whenever there is a flag or escape character in the text. Likewise. So At the end, trailer part or header part, there are flags. So after that flag, before that flag, header and trailer part will be there. Then escape character will be there. Every flag or escape, the escape character, escape character will be added. That is the data from upper layer. One stub the escape character, then extra 2 bytes will be added in that. Then at the receiver end, unstub the escape character, the data, original data will be received. Then frame in the bit oriented, this is the byte oriented, and now the frame in the bit oriented. At the flag, we are having certain bits at the same trailer part and header part. And in between the middle part, data from upper layer or variable number of bits will be there. So what is the tradition for bit stuffing? A bit stuffing is the process of adding one extra zero whenever 5 consecutive ones from follows zero in the data, so that the receiver does not mistake the pattern. Like 5 consecutive one, the zero will be appended for this flag, that is called as a bit stuffing. Likewise, so data from upper layer will be same. Then the stuff bit binary zero will be added after 5 consecutive one. Then extra 2 binary bits will be added. At the receiver receives that data, unstuff the extra by that stuff bit and get the original data. That is the in this way the bit stuffing will be processed or carried out. Then another point, flow and error control. The most important responsibility of the data link layer are flow control and error control. Collectively, these functions are known as the data link control. So data link layer is divided into 2 sub-layers. One is the LLC, logical link control, and second is the MAC, medium access control. So we have to give the brief description to our student about the data link layer is divided into 2 sub-layers. One is the MAC layer, another is the LLC layer. And who have done this role? The IEEE committee or IEEE association has deals this dividation of data link layer into 2 sub-layers. Out of 5 layers of TCP/IP model or out of 7 layers of OSI model, only data link layer is divided into 2 sub-layers, because data link layer play a very important role by flow control and error control process. So that's why we have to give the brief description to our student about the MAC layer as well as LLC layer. Although the separate layer is not mentioned in our syllabus, we have to give the brief description about that to our student. So flow control and error control. What is flow control? Flow control refers to the set of procedures used to restrict the amount of data that the sender can send before waiting for an acknowledgement. That is the flow control. So our channel should be maintain a flow of data. Our channel should not be overflow. To protect our data from misuse or overflow, for that purpose, the flow control method we are using. Error control in the data link layer is based on the automatic repeat request, which is the retransmission of the data. Whenever we are sending the data, then our channel is having not sufficient capability to send that data. It might be, our data might be overflow or some data might be lost in the form of loss of the packet, corrupt of the packet, or destroy of the packet, or a frame. In data link layer, we are working on the frame, the loss of frame, corruption of frame, or likewise. So in that case, how the error will be controlled by using certain mechanism, that is ARQ method or some error control method through which we are control the error by using that. So protocol is nothing but the how the data link layer can combine framing, then flow control, error control to achieve the delivery of the data from one node to another node. So these are the different protocols available. So detailed study is given for the student about these 2 different types of protocol under noiseless channel, simplest protocol, and stop and wait protocol. In noisy channel, under the ARQ, automatic repeat request method, ARQ, stop and wait ARQ, go back in ARQ, selective repeat ARQ. In noiseless channel means what? We are not detecting the error, we are not correcting the any type of error in noiseless channel. Only simplest way we are sending the data. simplest communication means one-way communication. Sending the data, we are not bothered about the flow control or error control. And second, stop and wait method, we are sending the data frame and waiting for the reply for that frame. Sending the second frame and waiting for the reply for the same frame. That is the noiseless channel, two methods. In noisy channel, we are having ARQ method, that is automatic repeat request method. In that case, we are detecting the error and we are correcting the error under this noisy channel method. How many number of frames we are sending, out of how many number of frames delivered successfully, how many corrupted, how many loss in between the transmission or transaction. So we are detecting the problem or error and correcting the error by using the ARQ method. Stop and wait ARQ method, go back in ARQ method, and selecting repeat ARQ method. In stop and wait ARQ, we are sending frame number 1 and waiting for the acknowledgement for frame number 1. As if the frame number 1 acknowledgement is received, then sending the second frame. Then acknowledgement number 2 is received, sending the third frame. Likewise, if the acknowledgement number is not received within a stipulated period of time, the retransmission of the same frame will be carried out under the stop and wait method. In go back any ARQ method, the whatever, suppose 5 frames we are sending, out of third and fourth frames are damaged, then we have to retransmit the third and fourth frame again. That is the go back in. The first frame to the last frame will be retransmitted again by using go back in ARQ method. In selective repeat ARQ method, the only damaged frame will be retransmitted. That is the intelligence of selective repeat method, but the complicated complication or some time space will be required for the more time space will be required for selective repeat method for searching the only particular damaged frame or corrupted frame. So I will not give in detail of each method. This is the brief overview of these protocols, but to our student, we have to give the briefly description of this all these methods. Then error detection and correction methods. Data can be corrupted during the transmission. For reliable communication, error must be detected and corrected. So connection-oriented network is the reliable network. Connection-less network is the unreliable network. Connection-oriented network TCP protocol is used, and we are having 100% assurance or guarantee. Whatever frames we are sending, we are receiving the acknowledgement of that frame, either loss of frame or negative acknowledgement or positive acknowledgement. That is called as reliable communication. And connection-less network is an unreliable communication. UDP protocol they are using, and we are not giving any guarantee of receiving the acknowledgement for the unreliable communication. Okay, so that is the reliable and unreliable communication. These are the types of error we are going to deal. Single bit error, then burst error. Single bit error is nothing but the only one bit in the data unit has changed. Suppose like this is the sender data bits, then receiver data bits. Sender sends one stream of bits, the receiver receives one stream of bits, but out of all the bits, 0 will be changed to 1. That is called as a single bit error. Then burst error means more than 2 bits are corrupt or damaged or changed. That is called as a burst error. Suppose in sender sends this topmost bit, then receiver receives the second row bits, but out of 3 bits are changed. 0 will be changed to 1. So the length of the burst is 5. Burst error length is 5 from first corrupted bit to the last corrupted bit. That is called as a burst length of that bit. That is the burst error. We can call it as a burst error. Then error detection method, redundancy method, parity check. Under parity check, we can have even number of parity or odd number of parity. Depends on your choice. You can adopt or use the even number of or odd number of. Then cyclic redundancy check, we have to generate the CRC bit, then append that CRC bit to the data bit, and then perform the thoroughly division. You will get the location where the error is occurred or data bit will be corrupted. Then checksum. some methods for the detection. Error detection uses the concept of redundancy, which means adding extra bits for detecting errors at the destinations. So here, the redundancy bit, sender node sends the data bits, then a redundant bit will be appended to that data bits at the sender side, and that data code word, after adding the redundant bit, it is called as a code word. That code word will be transmitted over the medium or communication physical channel. The receiver receives that bit, and after uh, eliminating the redundant bit, the original data will be received. If the original data will not match, the data bit will be rejected. Otherwise, the data bit will be accepted after the redundancy bit. So these are the detection methods. One is the parity check, either even number of parity or odd number of parity. Second is cyclic redundancy check by using CRC generator, generate the CRC at sender side and perform the thoroughly division, and you will detect the error at the particular location. Then checksum they are using for the detecting the error. So this is the even parity concept. At the sender side, data bits are sent, that is 11 4 times 0 1. Then calculate the parity bit. We are dealing with the even number of parity, means even number of binary 1 should be there. In our data words, the total number of binary 1 is 3. So our parity bit is 1, because we have to make it even number of binary 1. So for binary 1, that is the even number of 1, our parity bit is 1. So that data will be transmitted over the communication channel. Receiver receives that data and removing the parity bit. If the data is matched with the original data, the data will be accepted. Otherwise, data will be rejected. This is the even parity concept. Similarly, we can have an odd parity concept for odd number of binary 1. The same concept will work. In parity check, a parity bit is added to every data unit so that the total number of ones is even or odd for the odd parity. Okay. So simple parity check can detect all single bit error. It can detect burst error only if the total number of error in each data unit is odd. That is for odd number of parity. So normally we are dealing with the even number of parity. In two-dimensional parity check, a block of bits is divided into rows and a redundant row of bits is added to the whole block. That is the two-dimensional parity. Second method is CRC generator at the sender and receiver. Sender side, some data. This is the block diagram of CRC. Sender side, data will be there. Total number of binary 0 will be appended at the data. Then perform the thoroughly division. Then CRC n bit will be generated. Then that CRC bit will be appended to the generator, the data bits, and transmitted over the communication channel between the sender and receiver. Receiver receives that data bit and perform again thoroughly division. If the remainder is 0, then data is accepted. If the remainder is non-zero, then data is rejected. Okay. Like this is the binary division in the CRC generator sender side. So we have taken the data words, data bits 100 100. Then 3 binary data bits are added. Binary 0 30. So how many total binary 0 we need to append at the data bit? That is the total number of divisor bit. In our case, how many divisor bit? The 1101 means 4 bit. 4 minus 1. So 3 number of binary 0 we have to append at the data bit and then perform thoroughly division. Then at the end, we will get some remainder. That remainder, this is the sender side scenario, generator, CRC generator. We are generating CRC at the sender side. Append the total number of binary 0 means total number of divisor bit minus 1, 30 we are going to append. Then perform thoroughly division. At the end, we will get the remainder at the sender side. This remainder is called as a CRC. We are generated this 001 is the CRC generated at the sender side. So append that CRC generated to the data words or data bits. 001 is appended instead of 000. Then at the receiver side, again perform the thoroughly division, and at the end we will get the result that is remainder. If the remainder is 0, then data is not corrupted and received as it is. If the remainder is a non-zero, the data bit is corrupted and the data is rejected. So this is the generator sender side and receiver side CRC techniques. Then checksum, similarly, we are having n number of bits. Then we have to use the checksum, add some binary zeros to that n number of data bits and perform the ones complement at the sender side and send that after performing the ones complement with the sender side, send that data words or packet. We can call it as a packet or frame over the communication channel. Receiver receives that packet and remove the checksum bit by using ones complement method. If the bits are 0, then result is okay. There is our data is not corrupted. Data bits are accepted. If the remainder is non-zero, then the data bits are rejected and the perform the again same things or same process. Then error detection, retransmission, we have to retransmit the data. Once the error will be detected, then a forward error correction method will be there. Then burst error technique will be there, or burst error correction method will be there. So under this error detection method, so data and redundancy bit, we are having some combination of how many number of data bits we are using and how many number of redundant bits we need to append with that data bits. So this table gives a clear idea. If I am going to consider only one bit, data bit, I am sending one data bit, I require 2 redundant bit. My total bit length is 3. Suppose I am going to send the 4-bit data bit, then redundancy bit I need to append 3. Total data bit length is 7. Suppose I am going to send the 7 data bits, then total number of redundant bit is 4. Redundant bit is 4. I need to append, and then the total number of length of that data word is 11. So this is the how many number of redundant bit we required for a particular number of data bits whenever we are sending from one machine to another machine. So position of redundant bit in the Hamming code. This is the, in this case, we are having how many number of data bits? 1, 2, 3, 4, 5, 6, 7. D stands for data. 7 data bits. So in this table, 7 data bits, we require 4 redundant bits. Total 11 will be there. So 7 data bits we are using. We have to define the 4 redundant bits, R1, R2, R4, R8. And then the total code word will be generated at the sender side. That will be sent over the communication channel. Receiver will receive that code word, decode that code word, and check whether the data is corrected or corrupted data or correct data. This is the example, redundancy bit calculations. Suppose I want to calculate the R1 bit. So R1 bit deals with the bit position number 1, 3 at the top of this row. See the bit 1 number, 3 number, 5 number, 7 number, 9 number, 11 number. To define the R1 as an even number of parity, so 1, 3, 5, 7, 9, 11 position must be even number of binary one. The second row, to decide R2, bit number position 2, 3, 6, 7, 10, 11 is considered to define the R2 redundant bit for even number of parity. In third row, to define the R4, bit number 4, 5, 6, 7 is considered to define the R4 for the even number of parity. And to define the R8, the bit number position 8, 9, 10, 11 is considered to define this R8 binary or parity bit R8 or redundant bit R8. So in this way, you can have a one number, 1 data bit, 2 data bit, 3 data bit, 4 data bit, 5 data bit, 6 data bit, and 7 data bit. Accordingly, the number of redundant bit will be added, and accordingly, the total number of code word will be generated at the sender side, and that code word will be transmitted over the communication channel, and receiver will receive that code word and decode accordingly and check whether the data is correct or lost. This is the example of redundancy bit calculations. So I have sent it the data from the sender side 1001101. So total 7 bits I have considered and put it that 7-bit to the data position 3, 5, 6, 7, 9, 10, 11. So I have to consider, adding R1 means I have to decide the redundant bit R1. So for deciding the redundant bit R1, I am going to consider the bit position 3, 5, 7, 9, 11 for even number of parity and added the binary 1 because total number of binary 1 is odd in this data bit. So by adding binary 1, R1 equals to 1, I have made that binary as a even number of parity. So the value of R1 equals to 1. Then second, to decide the R2, the position, bit position 2, 3, then 6, 7, and 10, 11 is considered. So the already data bits are even number of parity. The value of R2 equals to 0. To decide R4, again the bit position 4, 5, 6, 7 is considered. So this is also again same, the binary parity, even number of parity is already there. So the value of R4 equals to 0. Then for deciding the R8, the value bit position 8, 9, 10, 11 is considered. So make it even number of parity, the value of R8 equals to 1. So in this way, we have decided the R1 parity, R2 parity, R4 parity, and R8 parity. And at the bottom layer, we are generated this code, that is 10011110101. That is the generated code by using the redundant bit for the even number of parity. Then pass on that code over the communication channel. Receiver will receive that code and check whether the data is correct or corrupted data. If the data is correct, then accept the data. If the data is corrupted, reject the data. Then retransmission is carried out again. So this is how the corrupted data will be detected. Again, we have to select the R1 position, check whether the binary 1 is the even number of parity, whatever 1, 1, 1, that is, then add R1 equals to 1. Then for R2, the binary position R2 value equals to 1. For R4, the value equals to again 1, and R8, the value equals to 0. So convert that binary R1, R2, R4, R8 in the decimal point. It will be converted into the decimal point. The position at which error is detected or occurred or bit is corrupted is identified. That is the method of detecting the position of corrupted bit. So this is the case study of CRC error detection in the Ethernet. We have to give the detailed description about the CRC, generated side, generator side, and receiver side, and accordingly, some practicals will be there based on the CRC. That is the case study, or some implementation will be there. So these are the textbooks which are included in the syllabus. First, Tannenbaum, that is the renowned author. Then Forozen, very simple language, they have written the book Data Communication and Networking. Then William Stelling, the Data and Computer Communication, latest version added in the syllabus. So these are the 3 textbooks suggested. Some references, some computer network, a top-down approach. Top-down approach means the physical layer, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. In that fashion, the syllabus is given in that that reference book, top-down approach. And second reference is computer network, that is the system approach, systems approach. These are the reference book. These are the e-resources or e-books available. We have added the ready-made e-books are there, and some tutorials are there. Some case studies are given in that tutorial. You may suggest to our student for the reference for the e-book or reference book or textbook. Thank you everyone for patience listening. Any question you can ask.
Thank you so much, sir. Participants, do you have any questions? Any questions from the faculties? Okay. Thank you, sir. Thank you very much. Your insightful explanation for fundamental concepts of computer network has
Madam,
provided.
hello, madam.
Yes, sir.
In the unit one, that point has not been covered, so I don't know because that is a new topic. That is telephone system, narrowband and broadband communication system. So what is to be covered in that? That I wanted to know.
Yes, sir. In that topic, just we have to cover communication system or the broadband or wireless network likewise.
So for this, which is the reference book for this particular topic?
In our reference book or textbook, that topic is included, already available, sir.
Okay. And
Yes.
second point is network hardware, and then there is a PAN, LAN, MAN, and WAN. But the network, this is not a network hardware. It is these are the types of networks.
Network.
Whereas network hardware is related with the switches, bridges, and gateways, all those things. So should we are supposed to discuss this also, the network devices under
Yes, sir.
network hardware?
Yes, in briefly, we have to discuss that network devices with the deployment of network, 20 machine network, which type of hardware required, latest configuration of hardware or devices we require. Suppose switch, hub, router, bridge, router, these are the hardware. We need to give brief description about that.
Okay. And sir, in the NSEM exam, will there be any questions on case studies, or this is just for under making the things clear for the students?
No, sir. That is for only student study purpose. There is no any question on NSEM exam for case study.
Thank you, sir.
Thank you.
Thank you, sir. Your insightful explanation of fundamental concept of computer networks has provided an excellent foundation for remaining sessions. Your vast academic experience and explanatory approach have greatly enriched today's orientation. Once again, thank you so much, sir. Now, I would like to request all participants to switch on their camera for a photo. We will take a screenshot. Please cooperate. Please switch on your camera. Thank you, participants. Thank you so much. Now we will take a 5 minutes break. We will be back in 5 minutes. Please stay connected. Thank you.
The recording has stopped.